All right, guys. Are there any questions over the homework before we get started? Okay.
Number 4. I got stuck.
Okay. So we're looking at number 4. So 2k squared minus 5k minus 18 equals 0. So the first thing we would look for is a greatest common factor between these three terms. And there is not one. So we'll have our two sets of parentheses with three spaces. Now we look at the third term. If the third term is positive, the signs are the same and they match the sign of the middle term. And if the third term is negative, our signs are opposite. So here, one is going to be positive, one is negative. Now we need to find the factors of the first and third term. So the factors of the first term, 2k squared, well, we'll know we'll have k and k. Well, the only factors of 2 are 2 and. So I'm just going to stick a 2 into one of those two spots. It doesn't matter which one we put it in, we're just going to put one in. Now we need to find the factors of 18. Well, we have 1 and 18, 2 and 9, 3 and 6. 4 doesn't work, and that's really the last possible one. Yeah, you can go on. Now looking at all these here, which set of factors do we want to try first? 3 and 6. And we can check this here. Now 2k times negative 6 is going to be negative 12k. 3 times k is going to be positive 3k plus 3k, which gives us a negative 9k. So that's not the one we want. So we can try switching the 3 and 6. So 6 and 3. Now this one here is not going to work. Because if we look at that first set of parentheses, what do we have? We have a 2 and 6 in the same spot, yes? Is there a greatest common factor between 2k plus 6? Well, 2 will go into both, won't it? So these won't work. I can still check it. 2k times negative 3 is negative 6k. 6 times k is going to be plus 6k, which gives us 0k. So even if we didn't notice that, when we checked it, it still wouldn't work out. So we can try 2 and 9. Now because 2k and 2 would have a common factor of 2, most likely those aren't going to be together. So we'll put 9 there. And if we check this here, 2k times negative 2 is negative 4k. 9 times k is going to be plus 9k, and negative 4k plus 9k is a positive 5k. Is that what we wanted? Almost. It's the correct number, but wrong sign. So we can change our signs. Make this negative, make this. We could, but to do that, we would need to switch the 2k and k and the 2 and 9. We'd have to flip everything. So let's go back here. This is what we had, yes? So if I flip the 2 and 9 and say not, or 2 and 9 here, and we check this, 2k times negative 9 is negative 18k. 2k times 2 times k is going to be plus 2k, which gives us negative 16k. So just flipping that doesn't work, because we also have to flip the 2 and move it over here. Because we still need that pairing of having the 2k times 2 and the k times 9. We need those pairings, we just need the sign to change. And if we do this now, k times negative 9 is negative 9k. 2 times 2k is going to be plus 4k. And negative 9k plus 4k is negative 5k. But does that kind of make sense? So we could flip the terms, but we have to switch both of the k's and both of our numbers. Or we can just change the signs. So it's a little bit easier to flip the signs. Now at this point here, we do have two things multiplied together that equal 0. So we're either saying that k plus 2 is 0 or 2k minus 9 is 0. And for the first one here, we can subtract 2 from both sides, telling us that k is equal to -2. And for our other one, we would add 9 first, telling us that 2k is equal to 9. But then we would need to divide both sides by 2, telling us k is equal to 9/2. You could say 4.5, either one works. As long as it's the same number, that's all that matters. Any questions on any of this here? What we're looking at today is the difference of perfect squares. The difference of perfect squares. Whenever we have two perfect squares, a squared and b squared, whenever these two numbers here, or these two terms here are perfect squares, it's going to factor in the form of a plus b times a minus b. A plus b times a minus b. Where a is the first term and b is the second. So if we looked at, say, the example here, x squared minus 9, well, what term's being squared for x squared? Well, x. What times itself is 9? 3. So we're saying that this here factors to x plus 3 times x minus 3. Because we had one of these yesterday. We looked at x squared minus 25, yes? X squared is x times x, yes? What times itself is 25? 5. And when we factored this yesterday, we got x minus 5 times x plus 5. It's a difference of perfect squares. Well, this is exactly the one we just did. X squared minus 25, yes? This is a difference of perfect squares. Because what times itself is x squared? Well, x, yes? What times itself is 25? 5. So what we could say is that this is x squared minus 5 squared, where x is our a, 5 is our b. So it would be x minus 5 times and that's it. Now we could still follow the same methods that we've been doing, figuring out if there's a greatest common factor and factoring it out. And then seeing what times itself is x squared, what times itself is 25, and our signs would be opposite. We could still follow those same steps we've been doing, but if we notice that they're difference of perfect squares, we can kind of just jump straight to the answer, because these here are nicer. We ready for the next one? 4z squared minus 1. So we need to see if this is a difference of perfect squares. 4z squared. So what times itself is 4? 2 times 2. Well, z squared is z and z. So really we could say 4z squared is the same as 2z squared, because 2z times 2z is going to be 4z squared. Now what times itself is 1? 1. So here our a is 2z, our b is 1. So we could say that this factors 2z plus 1 times 2z minus 1. that's it. Questions on this here? We ready for the next one? X squared minus 64. It is, well, x squared is a perfect square. X times x, yes? Is 64 a perfect square? It would be what times what? 8 times 8. So we could factor this to what? X minus 8 times x plus 8. It doesn't matter if we put the minus first or plus first, but we do need to include both. Questions on this here? Are you ready for the next one? Is this here a difference of perfect squares? Because x squared is x and x, yes? What's 36 going to be? 6 and 6. So what would this factor to? X plus 6 times x minus 6. Questions on this here? We good with these here so far? I mean, some of these could have a greatest common factor. We could have a common factor between both that'll bring it down so that they do work out, and sometimes they won't. So if we look at this one here, is 100 a perfect square? 10 and 10. Is m squared a perfect square? Well, yeah, m and m. So how would we write this? So what number came first? 100. So what number will go first? 10, because 10 and 10, yes? So we would say 10, and then what? Plus m and 10 minus m. We're used to having the variable go first, but it doesn't have to go first. Because whatever is numbered multiplied by itself is first. So here we had 100, which is 10 and 10. So the 10s would go first. Since the m was second, it would go second. I mean, if I wanted to, I could rewrite this, because 10 plus n and m plus 10 are the same thing, yes? Is m minus 10 the same as 10 minus m? Because which one has the negative in blue? Which one has it on bottom? The 10. Because the one in red has the 10 being negative, the one on top has m being negative. Yes. Because if we wrote it as negative m plus 10, then it would be the same. Now, the only way we could have it as m minus 10 is if I have a negative out front. Essentially, I factor the negative out of both 10 and m, because if we factor it out, the m becomes positive, but the 10 becomes negative. It's just hanging out here instead. But it's easier just to do it this way, because again, trying to keep all the negatives straight is sometimes a little challenging. Because this is perfectly fine. Any other questions on this here? Let's look at this one here. 25b squared minus 36. I think they might have gotten a little out of order. Yes? Yep, I'll have to fix that later. What times itself is 25b squared? What times itself is 25? What times itself is b squared? So, in our two sets of parentheses, the first term is 5b and 5b, yes? Is 36 a perfect square? It is. And then we just need our signs, positive and negative. And I mean, one way we could check to see if the numbers are perfect squared is taking the square root of it. We can't take the square root of b in the calculators because it needs a value for it, but we could plug Square root of 25 and see if we get a number. Square root of 36 and see if we get a number. Questions on this here? And that's really it. Do you feel comfortable with these here? All right. Let's look at the next part. Use the special product pattern to evaluate this here. Well, what have we been saying? If we have two things that are perfect squares and they're being subtracted, we could rewrite this. So really, I could rewrite this as 54 minus 48 times 54 plus 48, because this here is a difference of perfect squares. 54 minus 48 is what? 6, isn't it? 54 plus 48. Well, 4 and 8 is 2, carry the 1. 5 plus 4 is 9, plus 1 is 10. And 6 times 102. Well, 6 times 2 is 12. 6 times 0 is 0. Plus 1 is 1. And 6 times 1 is? So 54 squared minus 48 squared is 612. So any questions on this one here? 54 squared minus 48 squared. So if we looked at 68 squared minus 62 squared, we could do this as 68 minus 62 times 68 plus 62. Well, 68 minus 62 is 6. 68 plus 62 be 0, carry the 1. 6 and 6 is 12, plus 1 is 13. I believe we should get 780. Calculator does it just fine. I mean, with any of these, we could just type them in the calculator. It'll do it just fine. Any questions on any of this here? That's it. That is all we're doing today. So your homework is problems 3 through 12. I think you might have enough time to get it all done.
Is it okay if I come borrow your phone?
That's fine.